Whew. Hey everybody, this is Larry. This is... I'm so tired. I'm always tired. Day 4 of the Leetcode December Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Today we have 2211 count collisions on the road. Okay, yeah, let's count. I have nothing to say. I'm gotta just have a rest day. Because these days, every weekend I've been doing stuff. And weekday, I've been just also doing stuff. So I need like a rest day where I just literally do nothing. Maybe next week. Because this weekend, I am going to see penguins. More on that later, hopefully. But anyway, let's take a look at today's problem. 2211 count collisions on a road. There are n cars on an infinitely long road. The cars are numbered 0 to n minus 1 from left to directions of I could be left or right or S. Like staying, okay, so S is just not moving. Same speed, okay. Number of collision is when two cars move in the opposite direction, number of collision increases by 2. If a moving car collision is stationary car, right? After collision, the cars involved can no longer move and will stay at the point where they collide. Other than that, the cars cannot change their state or direction of motion. Alright, so it seems like a simulation E problem. I mean, N is pretty big, so you probably have to be a little bit smarter about simulation. One thing that I will do right now is look at the example, because I'm not quite sure what they mean by no longer move and stay at the point where they collide. Because does that mean like other stuff could collide later, or okay, right? Because 0 and 1, these things collide. Okay, and then R collides with S. S collides with L. Okay, I mean, this makes sense, right? 2 and 3 will collide. S and L will also collide. 4 and 5. Okay, so that's the part that I wasn't clear about from reading the problem. After 4 collides with 3, this and then gets hit by 5. Okay, but when 0 and 1 collide with each other, where are they? Do they stay at 0 and 1? What is the point of collision? The point of collision is at the S, I guess, in this one. But what's the point of collision of L and R? This is a little bit, I mean, I don't know. It's just not very clear what... It's not quite clear where they do it, but maybe it doesn't matter, right? But I'm just curious why. Yeah, okay, fine. Yeah, I mean, I think for a problem like this, the key thing, it's still still just try to find what I call an invariant. It's not, well, I don't mean to suggest I'm the only one that calls it that, but yeah, right. And the thing that here is that it's easier to kind of think about this problem the opposite way, right? Where I want to say every S does nothing, right? I mean, it can get collided with, but it does not. Because 2 S's will never collide with each other because they both are not moving. So then it has to combine with an L or R. But in that case, then they would get the contribution. So S basically doesn't have anything to the score, right? And then maybe you could also say it the other way first, which is that if you have L and R will always have +1, right? The only thing that doesn't give you a +1 each, because if an L or an R collides with each other, then it's 2. If an L and R collides with an S, then it's +1. So each L is +1 and each R is also +1. Except for, well, in example 2, right? Where you have on the edges going to the right and going to the left. So I think that's it, right? You just count the number of L's and R's, you subtract it from the number of L's on the left side and R's on the right side, and I think that's it, right? I think so. I guess we'll see. If not, then I don't know. That we will be sad, right? Okay, so then now we just count L's and R's total, right? I mean, you could do this in a number of ways, of course, implementation wise. You could, count them and then do some Boolean state thing, and but for me, I'll just do them like this, where maybe count is equal to directions.count L plus directions.count right. And then now we just have to subtract out the number of prefixes of L, right? Yeah, so then I know how to write check for prefix, of course. I'm just trying to think whether there's like a clever Pythonic way of doing it, but maybe not. Maybe there is, maybe there isn't. I don't know. But for C in directions, right? So if C is not equal to L, then we break, else we subtract 1, right? Because it's escaping, and then we do the same thing in the opposite directions. We count backwards. If C is not equal to R, we break. Otherwise, we subtract 1, and then we'll see, right? YOLO submit, and there you go. Yeah, okay. Went better than expected, which is what I needed because I was so tired yesterday. Oh yeah, I was going to do a quick intro of something. I haven't done anything interesting lately, but I wanted to show an image of. Yeah, can you see that? Amazon screen. Yeah, so this is. I mean, I guess this is an extra more than an intro, but yeah, this is my photo from what you would call it, from El Chatan, Frisboy, Patagonia, whatever you want to say. Is so I don't know, it looks pretty good if you ask me. Okay, maybe not the pixel peep, but in any case, I don't know. I don't have a fancy intro. Maybe I should. Maybe I'll do it again tomorrow. So if you see it again tomorrow, it's because I forgot to do it as an intro. But yeah, hope you enjoy it. I think there's a version with me in it, but without the good light because I don't know. Maybe I could have. I don't know. Is it worth it? In any case, that's all I have with this one. Let me know what you think. Thanks for watching. Stay good. Stay healthy to good mental health. I'll see y'all later and take care. Bye bye. Oh wait. I forgot to do complexity. I always forget, kind of, because it's for problems that are where it's not that interesting. This is linear time, constant space, right? That's why I mean I definitely should be more proactive about it, but it's just something that like when I saw n is big, I knew that if we can figure out either linear or n log n type thing, they'll be fast enough. But of course, if it's linear, then I don't have to really look at n, right? I look at this, it's linear, it's all one space. I don't have to see if it's fast enough because that's the lower bound usually, right? I mean, not always, but for Leetcode purposes, if you could do better than linear time, it rely on this input structure to be something different, or like pre-processed or whatever. But anyway, that's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.